Magandang araw po sa ating lahat. Naimbag nga aldaw kanya tayo amin. This is part 2 of solve problems in alternators in parallel. Link is provided for part 1 in the description below. Tuloy po natin at ang isosolve naman natin ngayon ay ang currents. These are the equations na gagamitin natin pero intindihin po natin ang principles na nakalagay dito. These equations will only be used if we have only two generators in parallel. Pero ang principle nito is that the total current is equal to the current delivered by the present generators. Kung meron naman tayong mas madaming generators in parallel, example tatlo, therefore, we have I total equals IA plus IB plus IC. Kung apat na generators naman ang connected in parallel, therefore we have I total equals IA plus IB plus IC plus ID. Or pwede rin naman natin gamitin ang equation na to which is equivalent to I total equals IG1 plus IG2 plus IG3 plus IG4. It depends on how you represent the currents in each generator. Huwag po nating kalimutan ang principle behind these equations. Anyway, mag-solve na po tayo. Umpisan natin sa problem number 1. Basahin po natin, two alternators are connected in parallel to supply a load at 3.3 kilovolts. The total load is 4,250 kilowatts at 0.85 power factor lagging. Alternator A operates with a load of 2,125 kilowatts at 0.707 power factor lagging. Determine the current supplied by generator B. Ang hinahanap po natin ay ang current galing sa generator or alternator B. Meron tayong dalawang alternator supplying a total load. Using Kirchhoff's current law at this node, meron po tayong I total equals IA plus IB. And since ang hinahanap natin dito ay ang current mula dito sa generator B, therefore, transpose po natin ang current IA dito sa kabila ng equation. Kaya magkakaroon po tayo ng IB equals I total minus IA. To simplify this equation, ito po yan, IB equals I total minus IA. Huwag lang natin kalimutan na included po dito yung mga respective angles nila. Now, let's solve IB using this equation. Kailangan muna natin kunin ang values ng I total at saka nung IA. To do that, from the formula of the real power, which is power equals square root of 3 times current times voltage times power factor. Cross-multiply lang po natin yung square root of 3 voltage and power factor dito sa kabila ng equation. Magkakaroon po tayo ng current is equal to the real power divide this by square root of 3 voltage and power factor. Ito ang magagamitin natin to determine I total and IA basing from this equation. Unahin po natin dito yung total current. I-substitute po natin yung total power dito which is 4,250 kilowatts. Divide this by square root of 3 and also the voltage which is 3.3 kilovolts and its power factor which is 0.85. Therefore, we have here 874.773 amperes. Pero syempre, kailangan din po natin kunin yung kanyang angle. Therefore, using this formula, na-derive po natin ang formula na ito from power factor which is equivalent to cosine theta. So, substitute lang po natin yung ating power factor dito, that is 0.85. So, the inverse cosine of 0.85, this is 31.788 degrees. Therefore, pwede po nating isulat yung I total into 874.773 angle negative 31.788 degrees amperes. Negative po siya dito again dahil meron tayong power factor na laging doon. Ngayon nakuha na po natin yung I total, kunin naman po natin yung current being delivered by alternator A. Using this formula, substitute lang po natin yung mga values dito. 2,125 kilowatts, divide this by square root of 3, 3.3 kilovolts, and 0.707 na power factor. So we have here 525.854 amperes. Kunin naman po natin ngayon yung kanyang angle using this formula. Substitute lang po natin yung 0.707 na power factor po dito. The inverse cosine of 0.707, this is equivalent to 45 degrees. Therefore, yung IA po natin is equal to 525.854 angle negative 45 degrees amperes. Again, negative po yan dahil ang kanyang power factor ay lagging, which is very common po. Ngayon nakuha na po natin yung values ng I total and IA dito. Substitute na po natin dito sa equation na ito. We have 874.773 angle negative 31.788 degrees amperes minus 525.854 angle negative 45 degrees amperes. Ang sagot po dito ay 382.225 angle negative 13.461 degrees amperes. Nakuha po natin yung sagot na ito using yung complex mode sa calculator natin para maging shortcut po yung solution natin. Tandaan po natin yung mga principles behind these solutions. Madali lang po itong gawin. Next, we have problem number 2. Two identical alternators A and B share equally a load of 15 megawatts at 33 kilovolts and 0.85 power factor lagging. The synchronous reactance of each alternator is 5 ohms per phase and the armature resistance is negligible. Alternator A has its field excitation adjusted to carry 160 amperes lagging current. What is the current supplied by alternator B? So current ng alternator B ang hinahanap po natin, therefore we use this equation. Tandaan po natin, wag po nating i-memorize ang equation na ito. Intindihin po natin yung pinanggalingan po ng equation na ito. Therefore, kukunin po natin yung I total and yung current being delivered by alternator A. Unahin po natin kunin yung total current gamit po yung formula na na-derive natin kanina. I-substitute lang po natin yung mga values. We have 15 megawatts divided by square root of 3, 33 kilovolts, and 0.85 na power factor. Ang sagot po dito ay 308.743 amperes. Wag lang po tayo malilito dun sa megawatts, which is million po ito, and yung kilovolts dito, which is 1,000 po yan. Ngayon kunin naman po natin yung angle using itong formula na ito. Substitute lang po natin yung 0.85 na power factor doon. We have inverse cosine of 0.85, that is 31.788 degrees. Therefore, we have I total equals 308.743 angle negative 31.788 degrees. Again, lagging power factor po tayo kaya meron tayong negative dito. Ngayon, sunod naman po natin kunin yung IA dito. Kung tutusin, meron na po tayong value niya dito. We have the 160 amperes. So, yung angle na lang po yung kukunin natin dito. Para makuha po natin yan, we use this formula. Cross-multiply lang po natin dito sa kabila ng equation yung square root of 3 current and kanyang voltage. So, we have the power factor equals the real power divided by square root of 3 voltage and current. Anyway, yung power factor ng alternator A ang hinahanap po natin. So, we have this formula derived from this one. Substitute lang po natin yung mga values dito. Pero, meron po tayong nakalagay dito na alternators A and B share equally a load of 15 megawatts. Ibig sabihin po yan, pareho po ng load sina alternators A and B. Pareho po sila ng megawatts na load. 15 megawatts, divide po natin ito ng 2 para makuha natin yung load ng bawat generators. So that is 7.5 megawatts. I-substitute lang po natin yung mga values na yun. 7.5 megawatts, divide this by square root of 3, 33 kilovolts, and 160 amperes. Therefore, we have here 0.82. Ngayon nakuha natin yung power factor ng alternator A, kunin naman po natin yung kanyang angle. So we have the inverse cosine of 0.82, ang angle po dito ay 34.915 degrees. Combining it with 160 amperes at lagging power factor, so syempre meron tayong 160 angle negative 34.915 degrees amperes. Ngayon nakuha na po natin yung mga values dito, substitute po natin sa equation na ito. We have 308.743 angle negative 31.788 degrees amperes minus 160 angle negative 34.915 degrees amperes. Magkakaroon tayo ng 149.237 angle negative 28.435 degrees amperes or simply 149.237 amperes. So, ganun, intindihin lang po natin yung problem kung paano po natin masosolve ito. Puntaan naman po natin itong problem number 3. Two Y-connected or star-connected alternators A and B running in parallel supply the following loads at 3.3 kilovolts. Load 1, 800 kilowatts at unity power factor. Load 2, 600 kilowatts at 0.8 power factor lagging. Load 3, 400 kilowatts at 0.707 power factor lagging. If alternator A is adjusted to carry an armature current of 150 amperes at 0.85 power factor lagging, what is the armature current of alternator B? So yung current ng alternator B ang hinahanap natin po dito. And we have the loads 1, 2, and 3. So ang gagawin po natin dito, kukunin po muna natin yung total load ng generators para makuha po natin yung total current. So we use this equation to determine the total load current, I1 plus I2 plus I3 dito sa load side. IA and IB naman po ang representation ng currents ng alternators A and B dun sa generator side. Again, mula sa formula na ito, derive lang po natin para makuha natin yung formula na gagamitin para dun sa current, which is equivalent to the real power divided by square root of 3 voltage and the power factor. Unahin po natin ngayon kay I1. Substitute lang po natin yung mga values. 800 kilowatts divided by square root of 3 divided also by 3.3 kilovolts and power factor na unity which is equivalent to 1. Ang sagot po dito ay 139.964 amperes. And since meron po tayong unity power factor dito, therefore yung angle po nito ay 0 degrees. So I1 is 139.964 angle 0 degrees amperes. Ngayon naman po kunin natin yung I2. Mula sa na-derive nating formula kanina, substitute lang po natin yung mga values. We have 600 kilowatts divided by square root of 3, divide it also by 3.3 kilovolts and 0.8 na power factor. We have 131.216 amperes. At hanapin din po natin yung kanyang angle using this equation. So we have the inverse cosine of 0.8, that is 36.87 degrees. Combine po natin siya dito sa value na ito. We have I2 is therefore equivalent to 131.216 angle negative dahil lagging po yung power factor niya, negative 36.87 degrees amperes. Ngayon naman kunin natin yung current ng load 3. So mula sa formula na na-derive po natin kanina, substitute lang po natin yung mga values. 400 kilowatts divided by square root of 3, divide that also by 3.3 kilovolts and 0.707. Magkakaroon tayo ng 98.984 amperes. Kunin naman po natin yung kanyang angle. Inverse cosine of 0.707, that is 45 degrees. May lagging na power factor po yan, kaya kapag kinumbine natin sa value ng I3, we have I3 equals 98.984 angle negative 45 degrees amperes. Ngayon nakuha na natin yung mga currents ng I1, I2, and I3. Substitute lang po natin sa equation na ito. Using yung complex mode sa calculator po natin, ang sagot na makukuha po natin dito ay 348.279 angle negative 25.279 degrees amperes. Ngayon nakuha na natin yung value ng I total. Kunin naman po natin yung value ng IA. Meron na po tayong value ng 150 amperes dito, therefore yung angle na lang po ang kukunin natin para kay current IA. So we have inverse cosine of 0.85 na power factor lagging. We have here 31.788 degrees. Combine natin siya dun sa 150 amperes. Again, take note, lagging power factor po tayo dun kaya meron tayong negative dito. So IA equals 150 angle negative 31.788 degrees amperes. Ngayon nakuha na po natin yung values ng I total and IA. I-substitute po natin sa na-derive nating equation kanina dito. We have IB equals 348.279 angle negative 25.279 degrees amperes minus 150 angle negative 31.788 degrees amperes. Sagot po dito ay 199.970 angle negative 20.401 degrees or simply 199.970 which could be rounded off to 200 amperes. We have our last problem, number 4. Hopefully, naiintindihan na po natin yung principle behind our solutions po dito. Okay, basahin po natin yung problem number 4. Two alternators running in parallel supply the following loads at 6.6 kilovolts. 400 kilowatts at unity power factor, 500 kilowatts at 0.9 power factor, and 600 kilowatts at 0.866 power factor lagging. One machine is loaded to 1,000 kilowatts at a power factor of 0.92 lagging. What is the current supplied by the other machine? So yung current ng isang machine ang hahanapin natin. Sabihin po natin IB po yon. And yung isang machine na may load na 1,000 kilowatts, sabihin natin that is generator A. At dahil meron tayong dalawang alternators connected in parallel, therefore gamitin po natin yung na-derive pa rin po nating equation kanina to determine the current of the other machine, that is IB. So kukunin natin yung mga values ng I total and IA dito. Pero yung load natin, meron tayong tatlo. So similar problem ito dun sa problem number 3. Kunin po muna natin yung total current using this equation. Mag-umpisa tayo dun sa I1. Substitute lang po natin yung 400 kilowatts at saka yung power factor na unity which is equivalent to 1 and yung voltage which is 6.6 kilovolts. Kaya meron tayong 400 kilowatts divided by square root of 3 divided by 6.6 and 1. That is 34.991 amperes. At ang angle po nito ay 0 degrees kasi meron tayong unity power factor doon. Now let's go to I2 using this equation. Substitute lang po natin yung mga values. That is 500 kilowatts divided by square root of 3, 6.6 kilovolts and 0.9 power factor. Ang value po nito ay 48.599 amperes. Kunin naman po natin yung kanyang angle using this equation. Substitute lang po natin yung 0.9 na power factor doon. So the inverse cosine of 0.9, this is 25.842 degrees. Combine natin dito sa I2. Therefore, we have 48.599 angle negative dahil lagging po doon. Negative 25.842 degrees amperes. Ngayon naman, I3 ang kunin natin. From this formula, substitute lang po natin
600 kilowatts divided by square root of 3, 6.6 kilovolts and 0.866.
Therefore, we have 60.608 amperes. Ngayon naman kunin natin yung kanyang angle, the inverse cosine of 0.866 power factor, that is 30 degrees. Combine natin ito dito sa I3, we have 60.608 angle negative 30 degrees amperes. Ngayon nakuha na natin yung mga values ng I1, I2, and I3. Substitute po natin sa equation na ito. We have here 34.911 angle 0 degrees amperes plus 48.599 angle negative 25.842 degrees amperes plus 60.608 angle negative 30 degrees amperes. Ang sagot po dito ay 140.958 angle negative 21.424 degrees amperes. At ngayon nakuha na po natin yung total current, therefore yung current A naman po or yung current IA ang kukunin natin. I-substitute lang po natin sa na-derive na formula na ito. We have 1,000 kilowatts divided by square root of 3, 6.6 kilovolts, 0.92 na power factor, that is 95.084 amperes. At kunin naman po natin yung kanyang angle, 0.92 po yung kanyang power factor doon. The inverse cosine of 0.92, we have here 23.074 degrees. At dahil power factor niya po ay laging doon, magiging negative po siya pag kinumbine natin sa value ng current IA. IA equals 95.084 angle negative 23.074 degrees amperes. At ngayon nakuha na po natin yung values ng I total and IA. Kunin naman po natin yung value ng IB. Substitute lang po natin ito dito. And we have 140.958 angle negative 21.424 degrees amperes minus 95.084 angle negative 23.074 degrees amperes. Ang sagot dito ay 45.995 angle negative 18.011 degrees amperes or simply 45.995 amperes or pwede po natin siyang i-round off into 46 amperes. Hopefully, nasasanay na po tayo sa pag-solve ng mga ganitong klaseng problems. Huwag po natin kalimutan, intindihin po nating maigi yung mga principles na ginagamit po natin. Anyway, maraming salamat po. Magandang araw po sa ating lahat, na imbag nga aldaw kanya tayo amin.